Welcome to clickmyproject.com. Our product title is an efficient Bayesian PAPR reduction method for OFDM based massive MIMO systems. The abstract: in our product we are going to detect the problem of joint PAPR, that is peak to average power ratio reduction in orthogonal frequency division multiplexing in massive MIMO downlink system. In our product we are going to develop a PAPR reduction model that uses the multi-user interference cancellation in the OFDM modulated signal. By using the expectation algorithm maximization and along with generalized approximate message passing technique, we are going to increase the computation latency by decreasing the value of PAPR value. The flow diagram: the main objective of our product is to analyze the PAPR reduction that is used in the massive MIMO downlink receiver system of the OFDM modulated signal. Hence, for our process, we are going to develop a OFDM MIMO channel for our PAPR reduction techniques. The final value of the MIMO OFDM model is considered for the EM, TGM, GAMP, PAPR reduction analysis. From the PAPR reduction analysis, we are able to find that our massive MIMO downlink model reduces the computation latency compared with other models. The use of expectation maximization algorithm and GAMP technique in the PAPR reduction model gives the high computation value with compared to the other signals. In first, we are going to send a data into the OFDM MIMO channel. Initially, the data is pre-coded and reordered and taken as input to the MIMO input channel. The reordered data is now IDFT processed. IDFT means inverse discrete Fourier transform. After discrete Fourier transformed to our modulated signal, we are adding the cyclic prefixes and pilot signals to the modulated signal. The digital value of our signal is converted into analog by means of DAC converter, and it is passed through the noisy channel. At the receiver end, the analog to digital converter is again used that uses the conversion of analog values into digital values. Hence, the digital values are demodulated by means of removing their cyclic prefixes and pilot signal that are being used in the modulation in the transmitters. The demodulated signal is now passed through the endpoint DFT channel. The endpoint DFT means discrete Fourier transform. The Fourier transform demodulated signal is the raw signal that is being obtained from the OFDM massive MIMO downlink receiver system. And now this signal is used for the consideration of PAPR reduction analysis by means of using expectation maximization algorithm with truncation Gaussian mixture and GAMP techniques. By use of our proposed EM, TGM, GAMP model, the computation latency of MIMO system increases and reduces the hardware efficiency. Reduces the hardware and increases the efficiency. Next we see how our product works. In our product we are using a MATLAB tool. MATLAB 2013 version is being used. Now run our product by right clicking over run. The BER values for our product, that is bit error rate for our product, is being obtained. Now the graphs are being generated. Now let us see the graphs one by one. Now we are seeing a CCDF graph of the PAPR system. For the CCDF graph, that is cumulative complementary distribution function, we have plotted against the PAPR values. The cumulative complementary distribution functions are in semilog values. We find that our CCDF value for the corresponding PAPR is against only one is being obtained, that is above the range of 10 power minus 1 and within the range of PAPR is equal to 5. Next is the SCR performance for various schemes. SCR means symbol error rate. The SCR is plotted against the signal to noise ratio. The value of signal to noise ratio is in terms of dB decibels. Now the SCR values are in the range of semilog values and the signal to noise ratio values are plotted in x-axis with a range of 15 by the means of 5 each. Now the graph explains that it is the value of EM, TGM, GAMP, our proposed system, and the value of FITRA, fast iterative truncation algorithm, and zero fading and clipping. The graph shows that our signal to symbol error rate value decreases as the value of signal to noise ratio increases. From our proposed model, we are able to analyze that our proposed model has the least number of signal to noise ratio value compared with the zero fading, FITRA and other algorithm methods. Hence, from our SCR performance graph, we have analyzed that the signal to noise ratio for our proposed EM, TGM, GAMP system is very low and hence it works with high computation latency. Now we have considered the value of PAPR, multi-user interference, and OBR for different iteration indexes. We have considered the FITRA algorithm and our EM, TGM, GAMP proposed model. As the iteration index increases, our value, that is in the PAPR graph, it continuously reduces, and the MUI, it continuously reduces, and in the OBR system it continuously reduces. Compared with the FITRA algorithm, the reduction has been post system, as we infer that from the iteration value that is being index, that is being increased, our PAPR value is being reduced, and the multi-user interference cancellation, that is the main objective of a product, it mainly reduces. Hence, from this graph, it shows that our proposed system is able to produce high computation latency. Now the graph is plotted between the number of transmitting antennas that is being used in the base station. The PAPR values, MUI values, and OBR values are being considered, and our proposed method is being compared with the FITRA algorithm. It shows that for the three methods, our number of transmitting antenna increases, the value of a proposed value method being decreases. This shows that our product is being highly efficient. Finally, the graph is plotted against the amplitude and spectrum frequency of the sample index and OFDM index. Here we have considered four system models: the zero fading, clipping, FITRA algorithm, and our proposed model. From these four algorithm methods, it shows that our proposed system has the sample index versus amplitude value very low and the spectrum index versus OFDM tone value very low.